Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on SCR commutation, in that Class C and Class D commutation. As we know that commutation of SCR means the process of turning of process of SCR. Here we have two types: forced commutation and natural commutation. Natural, if we give AC supply, that is natural commutation. If we give DC supply, that is forced commutation. Already we discussed the Class A, Class B. Class A commutation is now known as the load commutation. Class B commutation is known as a current commutation. Next here, Class C commutation is a today we are going to explain Class C and Class D commutation. Here, Class C commutation is a impulse or complementary commutation. Class D means parallel capacitor or auxiliary commutation. And next another name is the voltage commutation. Next, the last one is the Class C commutation, that is external commutation. Next, under the natural commutation, Class F. Here Class C commutation, impulse or complementary commutation. So now here this is a circuit diagram for Class C commutation. Here supply voltage to commutating elements are R and C. Here capacitor R1, R2, two thyristors, capacitor T1 and T2. This is T1 and this is T2. So now here first here what I will do first, here first take two thyristor will be turn off first. Here two thyristors are in off mode, means the turn off means switch is open circuit, and turn on means that is switch is short circuit. Now here two thyristor T1 and T2 are in off position. So now turn on, T1 is turned on and T2 is off. So T2 is off means here current flows from, this is plus and this is minus, current flows from R1, T1 and back to the negative, and also current flows from R2 and here. Initially there are two assumptions. So capacitor voltage equals to VC equals to Vs, that is plus and minus, and this current is like this. And second assumption is I0 is constant. I0 is constant. And now here to turn off this now this T1 is turned on. So our job is to turn off this T1. So for that case, so I will turn on this T off. So I will turn on this T on. So T is on, T1 is on and T2 is on. So now here this is on means it is short circuited. So short circuited, and it is plus and it is minus, and here this is a thyristor and this is a capacitor. Capacitor acts as a minus plus and this voltage, and this reverse voltage we are applying to this is Vs. So reverse voltage, negative voltage we are applying to this thyristor T1. And now here turn off methods are either we have to apply the reverse potential or anode current is less than the holding current. So here we are applying reverse potential, this T1 will be off. So now here T1 will be off means here now T1 thyristor will be off. So now here we need to calculate this IT2 current. So now here IT2 current equals to this IR1 current plus IR2 current. So IR1 current plus IR2 current. So now here this IR1 current equals to V of S by this one. So here this current. So V of S by R1 plus, so this is minus, so this is minus, sorry, this IR here current is, so here this one is short circuited. So now here this one is T2. So now here T2 equals to, here what will happen, so R1. So now here this is minus IR1 equals to, this IR1 equals to minus IC of T. So plus this is VAC of by VS by R2. So now here what do you mean by this IC of T? So minus of this this IC of T. IC of T means here before going to calculate this determine this IC of T, first we need to determine VC of T. So VC of T equals, there is a formula, VC of infinity plus VC of 0 plus VC of Z infinity e power minus T by tau. E minus T by tau. So now here initial value is this is Vs and final value this is minus. So this is minus of minus Vs. So now here this final value is minus Vs plus e power minus T by this. This is RC circuit. So that RC circuit equals to this one. Current is flowing. This capacitor current is flowing through this R1 and this C. Now here this is R1 into C. So now here this equals to this equals to minus Vs plus 2Vs plus 2Vs e power minus T1 by R1 into C. This is VC of T. Now what about IC of T equals to, that equals to C dVC of T by dt, that equals to, if you derivative with respect to this one, that equals to, this is 0 and 2 Vs by R1's minus of R1 and e power minus T R1 of C. So now that equals to minus 2 Vs by R1 e power minus T R1 into C. This one. Now here if you substitute this one in this, so I T2 equals to minus of minus IC2 means here 2 2 Vs by R1. So this is plus by R1 e power minus T R1 of T plus, and next V1 Vs by R2. So this is the equation, IT2 equation. So now here what about the circuit, if you want to peak value of current. So peak value of I22 current equals to, here what will happen, substitute T equals to 0. So now here for that case what I will do here, so IT2 equals to Vs by R2 plus Vs by R1 e power minus T R1 of T, this one. So now here what about the circuit turn off time means, turn off time means the time for which SCR is in reverse bias. For that case it will goes to VC of this value, it must be 0. It comes to 0 if you do this one here, that T equals to, here the T equals to R1 into C into ln 2. So the time for which, here it will comes from minus Vs to the 0. So that Vc T equals to 0, that equals to T equals to R1C ln 2, the thyristor 2 turn off time, and this is the current IT2. And next here to turn off this thyristor one, same here T1, this turn off time for this thyristor T1 time is equals to R1C ln 2, and IT2 equals to R1 Vs by R1 plus Vs by R2 2Vs e power minus T by R1 of T. So this is the equation And next second, to turn off this, to turn off this one. So here to turn off this T2, so what we have to do here. So this is the assumptions are here plus and minus, and this is a Vs and current flows in this direction. So now here if you give the supply to this one, current flows here in this, and here through the thyristor T2, and here come back to the 0. And again another path is flows from R and C and this T2 and again negative. So now here what will happen, T2 equals to, now here to turn off this, so here this is turned on and the turn off this, the initially it is turned off, and now T1 and T2 are turned on. So now here to turn on means it is short circuited, this is minus and this is plus, here this is thyristor and here we are giving, so here this is minus and this is plus. So now here we are giving the reverse potential to this one, and here this current is, it's here like this. So now here we are giving the reverse potential to this one. So what will happen, this thyristor T2 is in off position. So for that case, what I have to do here, I need to calculate IT1. So IT1 equals to I V of S by R1 plus, sorry, V of S by R2 plus minus of IC of T. Sorry, here V of IT R1 plus IT R2. So IT R1 means here this one minus this IC of T and Vs by R2, and this value equals to Vs by R2. So this value equals to, first we need to calculate IC of T, means Vc of T equals to Vc of infinity plus Vc of S, Vc of 0 and Vc of minus Vc of infinity e power minus T by tau, means that is R2 of R2 into C. Tau value equals to R2C. So now this is minus Vs plus Vs plus minus Vs means this Vs e power minus T by R2 into C. So now this is minus Vs plus 2Vs e power minus T by R2 into C. So now here what will happen here? This is R1 and this is R2 is this one. Now here substitute in this, if you derive with respect to say IC of T equals to, here IC of T equals to this one 2 Vs by R2 C into C e power minus T by R2 into C. Here what we will do here, so this value equals to IC of T equals to 2 Vs by R2 e power minus T by R2 into C. This is minus, and next this is R1 plus so 2 Vs by R2 e power minus T R2. So this is the equation IT1 equals to. So now here this is equation. So now here to turn off this SCR, so this T1 SCR. So now here there is a formula, so that is minus Vs to 0. So now here Vc must be 0, means here this value equals to 0, means here T equals to R2 ln R2 into C ln 2. So here I to turn off this T2, so time T2 equals to turn off time for T2 equals to R2C ln 2. So this is the equation. So now here waveforms. So what are the waveforms here? So here I am plotting these waveforms. First IG1, IG2, VT1, IT1, VT2, IT2, VC, IC. So now here turn on T1. First here I am turning on T1. So now here VT1 value is this is short circuit, means this value is 0, and next it starts from here there is a value and uh, decreasing exponentially decreasing, and next here T1 when T1 is on, and next VT2 is increasing, and IT2 is 0 initially it is open circuit, and VC value is increases, so this is increases, and next IC value is, so it starts exponentially decreases, and next here what will happen, so this current is 0, VT1 is 0, and its value is constant, that is V1 by Vs by R1, and this VT2 is constant, and next here IT2 is 0 and VC is 0, and next IC is 0. So now here this is here in this case, so now here T1 T2 is on, T2 is on means here, so the V1 is will go into the negative voltage and again increases to positive values, and next here IT1 value is decreases to 0, and next 0, and next VT2 is value is 0, and next that value is 0, and next IT2 current will increases and same as this IT1 waveform, and next same VC is from the positive polarity to the negative polarity, and IC value is is minus VIC, and this is 0, and next turn, next here this is, next here thyristor T1 will be turned off, T1 will be turned off. So now here this VT1 is same as this one, this waveform, and IT2 is 0, IT1 is 0 means here like this it will get IT1, and next here VT2 is 0 means like this IT1, and next this IT2 is like this one IT1, and next here VC value is negative, that is minus Vs, and IC value is 0, and next T1 is turned on. So now here for that case, so these are the waveforms same as that this line is opposite to this one. So these are the waveforms. So I hope next class D commutation. Class D commutation means here the components are here TM main thyristor, this is TA, this is L, this is diode, this is capacitor. So this commutation is also known as a parallel capacitor commutation. Now here this is the supply voltage. Another one is the auxiliary commutation or voltage commutation. Here we have two assumptions: supply voltage VC equals to supply capacitor voltage is initially charged, and second one is, what is the second assumption? Load current is I0 is constant. So same as same components used in the class B commutation, same as in the class D commutation. Initially this VC equals to Vs. So how it will come? So initially if you give positive supply and negative supply and current flows from capacitor, this auxiliary thyristor TA, and here it goes to the load and come back to the this load. So what will happen here? What will happen? So now here what will happen first here? Now here this initial voltage is when it is reaches to this plus and minus Vs, and there is no potential difference between this acts as a reverse potential, and this will be open circuited. So now this thyristor TA is off and its initial voltage VC equals to Vs. So now here this second one, so it will be turned off. So this TA is turned off. So Vc equals to Vs. So plus and minus this first condition. Next assumption is the I naught is constant. So now here these are the two assumptions, and next here now I'm firing this Ig and current is flowing. So plus and minus current is flowing ITM, and this is I naught. So this is flowing from here, here and here from in this direction. So now here another path is flowing from inductor, diode and this parallel capacitor. Initially it is plus and minus. So now here this is LC circuit. So now here this capacitor there is a LC circuit and it stores the energy, and current is flowing through the inductor, and the inductor stores the energy in the form of magnetic field, and it will give the energy to this capacitor through this diode, and here it will discharges, and this is minus and this is plus, this is minus and this is plus, and this diode is in reverse bias. So this is minus and this is plus Vs. So now fire this TA, this is TM, and this now fire TA, this is minus and this is plus Vs. What will happen? It is acts as the short circuit, and we are applying the negative, and this is positive, means we are applying the negative potential to the main thyristor TM. So now this TM will be off. So main thyristor will be off. Again this minus and this plus means here. So now here, so in same position, current is flowing from here, 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 here. When it is reaches to the Vs and plus and minus, and again this TA is also in off position. In this way, TM main thyristor will be turned off. So now here, if you see the waveforms, so first waveform here, Ig1, Ig2, Vt1, It1, Vc, Ic and I0. So I0 is always constant. So first fire the T1. So what will happen? So Vt1 is 0. Vt1 is short circuit. Vt1 is 0. And It1 current starts from I0 plus It1 means Im. Main thyristor, I0 plus this ICP, current flowing in this direction. So now here, this from I0 plus ICP, this is ICP. So now here, and it is current initially charge and discharge. So now here voltage is initially positive, Vs, and it 0 and negative value, minus Vs. Current is IC is 0 to minus in ICP and 0, and load current is constant. So now here this condition, now fire. So here thyristor is turned on. So now here when it is this TM will be turned on. So TM will be turned on means here this is main thyristor, and now here what will happen? So Vt1 current is negative. We are applying reverse potential to this one. So, and next here It1 current is 0, and next Vc of current is, so minus Vs to the plus Vs, and current is this current is 0, and next I0 is constant, and next here after that it will be turned on. TM will be TA is turned off. Next here TM will be turned off. TA will be turned off. So here what are the equations here? This ICP equals to Vs sine omega t. Here Vs equals to Vs equals to ICP equals VR square root of LC, and here IC current equals to ICP sine omega t, and this capacitor current equals to VC equals to Vs cos omega t. What is the circuit? These are the equations. These are the equations. So here this is ICP and this is a ICP. This is I naught. Here circuit turn of time t equals to same, here minus Vs to 0. Here circuit turn of time means here same, here minus Vs to 0. V dt equals to 1 by c integral of I dt. If you simplify this, t equals to Vs into c by I. So this is circuit turn of time. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.